Today, our topic types of MOSFET devices. So here types of MOSFET devices. So FET is categorized into two types. One is junction FET or also called as JFET. Other one is MOSFET. MOSFET or metal oxide semiconductor FET or IGFET. IGFET means insulated gate field effect transistor. So JFET can be categorized into two types. One is N-channel JFET and the second one is P-channel JFET. N-channel JFET and P-channel JFET. So MOSFET can be divided into two types. One is enhancement MOSFET, and depletion MOSFET. Two categories, broad categories. So MOSFET means metal oxide semiconductor field effect transistor or IGFET or also called as MOST. MOST. MOST means metal oxide silicon transistor. So here enhancement mode or enhancement MOSFET can be categorized into one is N-channel enhancement MOSFET and P-channel enhancement MOSFET. Similarly, depletion MOSFET can be categorized into two types. One is N-channel depletion MOSFET and P-channel depletion MOSFET. So last sessions we've seen complete details about JFET. We studied different characteristics, transfer characteristics about JFET. What is saturation ID current, what is IDS, and what is IDSS, and what is pinch off voltage. Everything we studied in JFET. So another type of FET, we also called as IGFET. In IGFET also two types, enhancement MOSFET and depletion MOSFET. We will see today one by one. First, we will see the enhancement MOSFET, this one, enhancement MOSFET. Then we will see the depletion MOSFET. So enhancement is nothing but enhancement means increasing. Enhancement means increasing. Depletion means decreasing. Here current is increases, that is ID current. ID current is increases. Here ID current is decreases. Depletion means decreases. Okay. So types of MOSFET devices are MOSFET is classified into two types, enhancement mode MOSFET and depletion mode MOSFET. First, we will see the working principle. So here working principles means by applying the transverse electric field, nothing but voltage, across an insulator deposited on semiconductor material, the resistance of conducting channel of semiconductor material can be controlled. So in depletion MOSFET, the controlling electric field reduces the number of majority charge carriers available for conduction. In depletion, enhancement MOSFET application of electric field causes an increase of majority charge carriers in the conduction region of a transistor. So here increasing order, here reduces. So we know that depletion MOSFET is reduces the number of majority charge carriers. So number of decreasing. Here enhancement MOSFET means number of charge carriers is increasing, the majority charge carrier increasing. We know that FET is a unipolar device. FET is a unipolar device. That is, uni means one, either only majority charge carriers. Majority charge carriers only. Majority charge carriers only. So FET is a unipolar device. Only one charge carriers, majority charge carrier. Whereas BJT, bipolar means bi means two, either majority or minority charge carriers. FET means only unipolar, only one carrier, majority charge carriers only. So in depletion means number of majority charge carriers is decreasing, whereas enhancement mode, number of majority charge carriers are increasing. So this is the whenever transverse electric field applied. Okay, this is the principle of MOSFET. We will see in detail now. See, enhancement MOSFET. This is the construction and symbol of N-channel enhancement MOSFET. So we know that FET is a three-terminal device. The symbol of FET is, so this is the symbol of FET. So what is the first terminal? This one is the gate terminal. What is this terminal? This terminal is the drain terminal. This terminal is the source terminal. So across this voltage is VGS. This is the voltage. So this voltage is VDS. So this is the N channel FET symbol. So this is the similar to JFET. Enhancement MOSFET is similar to JFET, but small variations. Here we are using oxide layer. So you can observe this is one metallic bar. This one is one metallic bar. Here also one metallic bar. So both are N-type material. This one and this one both are N-type material. We call it as this one is a drain and this one is source. Similarly, here also here this is the metallic bar. This one is oxide layer, that is called SiO2. So it is aluminum bar. It is aluminum bar, not aluminum bar. It is the gate terminal. So this is the substrate means it is a P-type material. Substrate is nothing but P-type material. So only some portion is P-type material. So this is the description of N-channel enhancement MOSFET. N-channel enhancement MOSFET. Okay. So same thing we will see in graphical way. So this is the N. This is the N plus. What is the difference between N and N plus? Here N plus. Here also N plus. N plus is nothing but heavily doped. Plus means heavy, heavily doped. N means normally doped. N plus means heavily doped. Okay. So you can observe previous figure here two N's. This is one N and this is one N plus one. Two N's means here also same. See, this is one N and this is one N. That is N plus. We call it as N plus. This is also N plus. So similar to this one. Okay. This one and this one. Then what is this? What is this bar? This bar we call it as N plus bar. We call it as source. You can observe here. This N plus bar we call it as source. Similarly, other N plus bar we call it as drain. So other N plus bar we call it as drain. Okay, similar to this way. So this is the metal. This black region we call it as a metal. So below metal one layer is there. We call it as oxide layer. That is SiO2, silicon dioxide oxide layer. So in between this N plus and this N plus, in between one region is there. We call it as the channel. This one is the channel. This one is the channel. So this channel and this red line is there. We call it as depletion region. This is the depletion region. Out of the channel, we call it as depletion region. This P substrate. So this is the P substrate. Okay. This is the P substrate. P substrate is nothing but a semiconductor material, P material. So in a P-type material, what are the majority charge carriers? P-type is nothing but positive. Positive is nothing but holes. Holes are the majority charge carriers in P-type. What are the majority charge carriers in N-type? N means negative. Negative means electrons. Electrons are the majority charge carriers. Okay. So this is the construction of MOSFET. N-channel enhancement MOSFET. Why it is N-channel means if it is a P-type substrate means channel is here N, because here N plus 1 means here channel is N. If it is a N plus substrate means its channel is P. So this is the corresponding symbol of N channel enhancement MOSFET. We know that in FET, if arrow direction, conventional current direction into the bar we call it as N channel. Out of the bar we call it as P channel. We know the basic thing. So here this terminal is gate terminal. This is the drain terminal. This is the source terminal. See, this conventional current direction is into the bar. Is into the bar is nothing but it is a N channel. This is a N channel. If the bar is here, bar is out of the if the arrow mark is out of the bar means it is a P channel. That is the main difference between N channel and P channel. Here we call it as a gate voltage. This is because it is a gate terminal. Here we call it as a drain terminal. Means a drain voltage because it is a drain terminal. Drain VDS means voltage across drain and source. Voltage across drain and source. Okay. So this is the construction of N channel enhancement MOSFET. Okay. So I will describe there is only a single P region. This region is called as substrate. So this is only one P region. This is one P region. We call it as substrate. There is only a single P region. This region called as substrate. What is second point? Uh, Two heavily doped N regions are diffused in a lightly doped P-type substrate. Here, heavily doped two N regions. These are heavy, N plus means heavily doped. Two N regions are diffused into the P-type substrate. Diffused means inserted into the P-type substrate. So this whole box, we call it as a P-type substrate, we can say. So one N-type material is diffused into the P-type substrate. Here also, right side and other N-type material is diffused into P-type substrate. Okay. So third one is one N region is called as source and other is called as drain. So this is one N region, we call it as the source, and other N region we call it as the drain. Okay. So if the MOSFET is an N channel or N MOSFET, then the source and drain are N plus regions and the body is P region. Already we discussed this point. So this is a P-type substrate. If it is N-channel means source and drains are N-type material. So in between channel we call it as a N-channel. This one is N-channel because substrate is P. So a thin layer aluminum is formed over the layer of SiO2. This metal layer covers the entire channel region and it forms the gate. So this one is the gate terminal. This one is the gate terminal. This silicon layer forms the gate terminal. Okay. So the metal area of a gate is conjunction with insulating oxide layer of SiO2 and semiconductor channel forms a parallel plate capacitor. So here this is the N channel, this is oxide layer, and this is the metal. So this metal and N channel layer we call it it exists one mechanism, we call it as parallel plate capacitance because it is other material and gate is other material. Okay, that is called N channel enhancement MOSFET. So this is the N channel enhancement MOSFET. So this is the P-type substrate. P-type substrate. Heavily doped N materials are diffused into P-type substrate. Diffused means inserted into P-type substrate. Then it forms the N-channel enhancement MOSFET. Here this terminal, this metal we call it as aluminum metal. Below this metal, it is oxide layer, silicon dioxide oxide layer. In between N plus and N plus, there is a gap. We call it as N channel region. So this is the description. This is the respective symbol. This is the N channel because conventional current direction is into the bar. So this is called N channel enhancement MOSFET. Okay. So This is similar to P channel also. P channel is so this is N channel enhancement. What do you mean by P channel enhancement? But substrate is a N here. Instead of P, we are using N. Instead of N plus, we are using P plus. That is the main difference between N channel and P channel. Why the name is N channel means between the N plus region, there is a channel, we call it as N channel. If it is P channel means this is P plus and this is P plus. In between P plus region, we call it as a P channel. That is the main difference. Okay. So here, this is the same N channel enhancement MOSFET. Why it is N channel enhancement MOSFET means substrate is a P type substrate. Just here we are applying some external voltage. See, first point, if the substrate is grounded and a positive voltage is applied at the gate. So this is the battery. Positive voltage. So right side one is the plus and this one is minus. This one is minus, this one is plus. Positive symbol is connected to the gate. The positive charge on the gate. So positive charge means this is plus plus. So whenever battery, positive terminal of the battery is connected to the gate, so positive plus ions, we call it as holes. Charge on the gate induces the equal negative charge on the substrate side between source to drain. It will induces negative charges at the channel. So these negative charge of electrons, which are minority carriers in p-type substrate, forms an inversion layer. Actually, it is a p-type substrate. In a p-type substrate means majority charge carriers are holes because p-type means contains holes, n-type means contains electrons. So p-type substrate consists of majority charge carriers or holes. Whenever gate is connected to the positive, so positive charge carriers are induced into the channel. It establishes a negative charge carriers. These negative charge carriers in p-type substrate are the minority charge carriers. Okay, as the positive voltage on the gate is increases, so at small voltage less number of electrons exist. When large voltage more number of electrons exist. That is the meaning. As the positive voltage on the gate increases, the induced negative charge in the semiconductor increases. Hence the conductivity increases and current flows from source to drain through the induced channel. That's why we call it as enhancement, because here conductivity is increases. Increases means enhancement. Whenever more gate voltage is applied, more number of electrons are induced into the p-type substrate so that electrons move from source to drain. Then current passes from drain to source. That current we call it as drain current. See, whenever voltage is increases, VGS voltage is increases, more number of electrons are induced into p-type substrate. If more number of electrons are induced means current conductivity is increased from drain to source. Okay, this is called enhancement MOSFET. N-channel enhancement MOSFET. Okay. So this is the N channel. What is the conventional current direction is into the bar. Conventional current direction is into the bar. Here P channel. P channel means conventional current direction is out of the bar. So this is the N channel. This one is the P channel. Same process for P channel also. Just we studied N channel. Same similar process is applicable to P channel also. So the main here N channel, the substrate is a here the substrate. What is the substrate here? P type. P type is the substrate. This is called substrate. Here N type is the substrate. N-type is substrate. Here, which channel forms N-type is substrate means P-type materials are induced into the N-type substrate, N-type substrates, then N channel, P channel will be established. That's why we call it as P channel MOSFET. Okay. I am not discussing fully about P channel because it is similar to N channel also. Okay. Next, we will see the depletion mode of MOSFET. So this is the construction symbol and N channel depletion type. In previously we seen enhancement mode. Here this is the depletion mode. Depletion mode is current conduction is decreases. That is ID current, drain current is decreases. Depletion is nothing but decreases. See, you can observe it is similar to enhancement also. Here this is the P-type substrate, P-type substrate. And this one is N to N material or N plus heavily doped material are induced into the P-type substrate. Here voltage, negative voltage. In previous we are applying positive voltage. So this gate terminal is connected to negative terminal. So this is negative, this is negative, this is positive. This is negative, this is positive. So whenever negative voltage is nothing applied to the gate terminal means these negative electrons are induced into the positive electrons in the p-type substrate, p-type substrate. Okay, that is the operation of depletion mode. So here there is no gap here. In previous one there is a gap here. Here there is a gap. Two gaps are there in previous enhancement. Here there is no enhancement. P channel is nothing. Conventional current direction is opposite, means out of the bar. N channel means conventional current direction is into the bar. That is called depletion MOSFET. That is called depletion MOSFET. Okay. We will see in detail point by point. N channel N channel is diffused between the source and drain. N channel is diffused between the source and drain to the basic structure of MOSFET. It is similar to enhancement mode only. See here, N channel is diffused between the source and drain to the basic structure of MOS. So this is the N channel is diffused into the P-type substrate. Okay. When VGS is equal to 0, that means VGS is nothing but gate source voltage is equal to 0 and the drain at a positive terminal with respect to the source. That means drain is a positive. Positive terminal of the battery is connected to the drain and negative terminal of the battery is connected to the source. What happened? The electrons are majority charge carriers. Electrons are majority charge carriers flows through the channel from source to drain. From source to drain. That means current is passes from drain to source. Therefore, the conventional current ID flows through the channel from drain to source. So whenever electron movement is opposite mean current is, so this is the electrons. So current direction is reverse. So this is ID current. So this is source to drain. Electrons are moved. Current is moving from drain to source. That current we call it as drain current. If the gate voltage is made negative, positive charge consisting of holes is induced in the channel through SiO2, means silicon dioxide, or the gate channel capacitor. The introduction of the positive charge causes the depletion of mobile electrons, not electronics, mobile electrons in the channel. This is electrons. This is electrons. The channel. Thus, the depletion region produces in the channel. So, the shape of the depletion region depends on VGS and VDS. So, first VGS is equal to 0, drain current flows. Whenever VGS is increases or VGS is decreases, based on this parameter voltages, the shape of the depletion regions depends upon the VGS voltage and VDS voltage. So VGS voltage and VDS voltage. See, the negative charge of electrons, which are minority charge carriers. So here, drain characteristics of N-channel depletion type MOSFET. N-channel depletion type MOSFET. That means the negative charge of electrons, which are minority carriers. Why it is minority carriers means substrate is a p-type substrate, holes are the majority charge carriers. These, whenever negative charge of electrons, which are minority carriers in the p-type substrate, forms an inversion layer as the positive voltage on the gate. So gate terminal voltage is a positive. First we are applying 0. First we are applying VGS is equal to 0. Then we are increasing VGS is equal to some fixed voltage, that is positive voltage on the gate increases. What happen? The induced negative charge in the semiconductor increases. Hence, the conductivity increases and current flows from source to drain through the induced channel. So I will tell you one more time. Whenever first condition is VGS is equal to 0, ID current is very less. When VGS is increases, when VGS is increases gradually, so ID also increases. ID also increases. So that is the meaning, because of current flow from source to drain through induced channel. Okay. Next, we will see the drain characteristics of N-channel MOSFET. See here, a minute. Drain characteristics of N-channel depletion type MOSFET. When VDS, from the figure, we will see x-axis is VDS and y-axis is ID. That means VDS means drain source voltage. Here ID means drain current. So whenever VDS is increased, so this is the origin 0. Whenever VDS is increased, means this is the increasing path. Whenever VDS is increases, ID increases. Correct? So whenever VDS is increases means ID increases here. This is the ID increases from 0 to some value. And it becomes constant at certain value of VDS. So from this point, this is the VDS, this VDS, from this point ID is constant. It is not increased. Up to this point ID is increases. Up to this point ID is increases. After this point ID is constant. ID is constant at certain value of VDS. So this is the certain value of VDS, called as pinch off voltage. So this voltage we call it as pinch off voltage, because from this point, from this VDS voltage, ID current is constant. ID current is constant. So this VDS voltage we call it as pinch off voltage, that is VP, pinch off voltage. So the drain current ID almost get saturated beyond the pinch off voltage. From this VDS, this point, almost drain current is saturation. So it is a constant. from this point VDS VP, that is pinch of voltage. From the pinch of voltage, almost ID is constant. ID is constant beyond the pinch of voltage. Okay. The depletion MOSFET can also be operated in a enhancement mode also. How? It is only necessary to apply a positive gate voltage so that negative charges are induced into the N-type channel. Hence, the conductivity of the channel increases and ID increases. Okay, this is called as drain characteristics of N-channel depletion type MOSFET. N-channel depletion type MOSFET. Okay. So this is the transfer characteristics of N-channel depletion type MOSFET. So transfer characteristics means, so in previous, this one, VDS is increases some fixed values. VGS is equal to, we are fixing VGS is equal to +1, VGS is equal to 0 volts. We are fixing, for example, if VGS is equal to -1, we are fixed that voltage. Then varying VDS and measure the ID. Similarly, after some time, we have to vary the VGS voltage up to -2 volts. Then we have to vary the VDS voltage and corresponding ID current we will measure. So we will see these characteristics in ADE lab also. These characteristics we call as drain characteristics of N-channel depletion type MOSFET. Now we will see the transfer characteristics. So transfer characteristics is nothing but VGS voltage is decreases from 0. VGS is voltage is decreases from 0. Whenever VGS voltage is decreases from 0, -1, -2, -3, -4, -5. So ID current is also decreases. ID current is also decreases after some time. ID current is 0. After some time, current is 0. This point we call it as VP. VP means pinch of voltage. Pinch of voltage. Whenever VGS is equal to -6 volts, ID current is equal to 0. So this voltage we call it as pinch of voltage VP, or we also called as VGS off. VGS off. We also called as VGS. Here VGS off is equal to -6 volts. VGS off is equal to -6 volts. When current is maximum, whenever VGS is equal to 0. So this is the 0. Whenever VGS is equal to 0, current ID is maximum. ID is maximum. So that maximum current, that maximum drain current, we call it as saturated drain current. That maximum current we call it as saturated drain source current. Saturated drain source current. This S means saturated because it is the highest value whenever VGS is equal to 0. This point we call it as IDSS. IDSS is nothing but saturated drain current from drain to source. From drain to source. Drain to source from saturated. Why saturated? It is the maximum value. This is called transfer characteristics of N-channel depletion type. So it is similar to P-channel also. P-channel also we will get drain characteristics as well as transfer characteristics. These are similar to P-channel depletion mode also. Okay. Simply thing is P-channel means substrate is the N-channel. Here N-channel means substrate is the P-channel. So this is called MOSFET types. Okay. So today I will summarize what we discussed in this session. So in this session, we studied different types of MOSFETs. So first FET is divided into two types. One is JFET, junction FET. Other one is MOSFET. MOSFET is nothing but metal oxide semiconductor FET or metal oxide field effect transistor, are also called as IGFET, insulated gate field effect transistor, are also called as MOST, MOST means metal oxide silicon transistor. So in a previous session, we studied junction FET in detail. Today's session, we studied only MOSFET. So MOSFET is categorized into two types. One is enhancement mode, other one is depletion mode. Enhancement mode means current is increases. That is the name suggests. Enhancement means current conductivity is increases. Depletion means current conductivity is decreases. So MOSFET can be operated in two modes, enhancement and depletion. We studied enhancement drain characteristics as well as transfer characteristics. Similarly, in depletion mode, drain characteristics and transfer characteristics we studied. This is called MOSFET. Okay. Next class we will see the differences between JFET and MOSFET. So in previous session we studied junction differences between the junction FET and BJT. The BJT means bipolar junction transistor. So the difference between the bipolar junction transistor and junction FET we studied. So next session we will see the differences between the junction FET as well as MOSFET. Okay. These materials are available in Google Classroom also. You can go through that. If you have doubt, ask me next session. Okay. Okay. Thank you.